Imagine looking up at the night sky and realizing that among all the familiar stuff, the planets, the stars, there's a visitor.
Mm-hmm.
And not just any visitor, right? Something.
Mm-hmm.
Well, something really extraordinary from way beyond our sun's gravity, and it's heading right through our neighborhood.
It's pretty mind-bending when you think about it. We've had a couple before, of course.
Right, like Oumuamua and Comet Borisov. They were
Yeah.
incredible, yeah. But now we've got a new one, 3I Atlas. So today we're doing a deep dive into this fascinating object, 3I Atlas. A celestial traveler, like you said, originated far away, and it's currently on this brief but really significant tour through our solar system.
Mm-hmm. And quite a tour, it seems to be.
Our mission here is to unpack the details we have. There aren't many, but they're significant, and explore why scientists, from Harvard to observatories everywhere, are so completely captivated by it.
Makes sense. There's a lot to unpack.
Okay, let's unpack this. And this isn't just, another comet or asteroid we see all the time.
Mm-hmm.
This is different. It's a really rare chance to actually glimpse material from a whole other star system.
A cosmic immigrant, as you put it.
Yeah, right here in our cosmic backyard. So for you listening, it's kind of like finding this, geological time capsule.
That's a good way to think about it, carrying chemical fingerprints from its home system.
Exactly.
Yeah.
Clues about places we can barely even imagine. So 3I Atlas, interstellar object. Now, for listeners who follow space news, this means it started outside our solar system, not one of ours.
Correct. It's just visiting, passing through.
Right, a wanderer. But what makes this one, 3I Atlas, stand out? I mean, we had Oumuamua. Remember all the debate about its shape and lack of coma?
Oh, yes, definitely.
And Borisov, which looked more like a typical comet. So what's making this visitor so compelling right now?
Well, what's truly fascinating here, and what gives Atlas its unique draw, isn't just that it's interstellar. We've seen that, as you said.
Right.
It's the specific combination of things we're seeing, its characteristics. Each one of these objects, really, is like opening a window to another star system.
A free sample from a cosmic deli, maybe.
Ha, exactly. A chance to study material that's traveled, incredible distances. It gives us direct clues about composition, about processes happening way out there.
Without launching a probe that takes millennia.
Precisely. We look at its light, its spectrum, its path, and we can learn about the raw materials for planets around other stars, or even just the stuff between the stars.
Galactic archaeology, I like that.
It really is. And yes, scientists are watching it incredibly closely, monitoring its journey, trying to grab every bit of data before it leaves us again.
And when we talk about this wanderer, we're definitely not talking small. This is where it gets, frankly, a bit wild.
The scale is impressive.
Astounding. The NBC News report, it points this out, quoting Harvard astronomer Avi Loeb. It says, 3I Atlas could be twice as big as Manhattan.
Twice Manhattan. Let that sink in. Seriously. Try to picture that. 2 Manhattans, all the buildings, the parks, just hurtling through space.
It's not just a rock at that point.
No. It's practically a small world. A rogue planetoid, almost.
And if we connect that size to the bigger picture, it has major implications. Yeah. For starters, observability.
Easier to see, right?
Much easier. A bigger object means we can spot it, track it, maybe even study it in more detail with our telescopes, both here and in space.
So potentially better data than we got from Oumuamua.
Potentially, yes.
Yeah.
Higher resolution, maybe seeing surface features, signs of activity, things that were harder with smaller, dimmer objects. And its size also suggests, resilience.
Resilience? How so?
An object this big. It's more likely to have survived the tough journey through interstellar space, radiation, dust clouds, maybe gravitational nudges from other stars.
It's a survivor.
It's a survivor, yeah. Carrying its history across those huge cosmic distances. So monitoring its trajectory becomes absolutely critical, especially since the report says it will come very close to planets, including Mars and Jupiter. Close approaches.
Okay.
Not like collision. It's close.
Oh, no. Not a threat in that sense. But close enough for incredible viewing opportunities. Think about it. Maybe gravitational lensing effects. Or how Jupiter's huge gravity might subtly tweak its path.
Giving us clues about its mass.
Exactly. Or maybe we could even see some, transient atmospheric effects if it passes a gas giant just right. Or just get a clearer look at its surface, its composition from a better angle.
A chance to see something pristine up close, relatively speaking.
Precisely. Even from a distance, it's a valuable encounter.
Okay, that's fascinating. The resilience, the observation chances. So you combine this massive size with, its origins being mysterious.
Yeah,
It makes sense why ATLA is stirring things up.
definitely.
The NBC report, even in the related links, it mentions astronomers debating its mysterious origin.
Mm.
What kind of debate are we talking about here? What's so mysterious? Is it the composition, the
Mm.
path? What's making scientists scratch their heads?
Well, this really raises some important questions about what's actually out there between the stars. When scientists talk about a mysterious origin, they're not just, throwing darts.
Right. It's based on evidence.
Exactly. They're looking at a whole bunch of factors, all connected, like forensic science in a way. First, its composition. We look at its light spectrum. Does it match stuff from our solar system's formation?
Or is it completely alien?
Or is it fundamentally different? Maybe richer in certain chemicals, weird isotopes. If the ratios are way off, it could mean it formed in a really different place, like around a star with fewer heavy elements, or maybe even inside a supernova remnant.
Wow.
And second, its speed and path are crucial. Velocity and trajectory. Was it kicked out violently from a young star system, maybe flung out by a giant planet?
Or something gentler.
Or maybe gently nudged out of a binary system? Or, and this is a wild thought, maybe it even formed out there, in the interstellar medium itself, something really ancient.
So the way it's moving tells a story.
Absolutely. Where it's coming from, how fast it's going, if it's spinning, that tells us about the kick it got and the environment it left. For example, if it shows no comet activity, no tail, but it's spinning fast, is it a dead comet?
Or something.
Or maybe a piece of a rocky exoplanet? It really challenges our ideas about how matter gets distributed in the galaxy. What kinds of objects are actually floating around in that vast emptiness between star systems?
Huh. So yeah, a cosmic riddle wrapped in a giant,
Mm-hmm.
giant something. And speaking of spotting it, it's also really interesting that our planetary defense systems picked it up.
Yes, that's significant.
The report mentions planetary defense system spots interstellar object. Now, for most people, planetary defense probably means, Bruce Willis saving Earth from an asteroid.
Right, the Hollywood version.
But this detail shows these systems have a much broader role, don't they?
Absolutely. Their role goes way beyond just looking for potential Earth impactors. Systems like NASA's Planetary Defense Coordination Office, using telescopes like Pan-STARRS, Catalina Sky Survey, they're constantly scanning the sky.
Always watching.
Always watching. And yes, their main job is to find and track near-Earth objects that could be a threat. But their technology, their capabilities for observation and tracking are just invaluable for pure science, too.
So they find interesting things even if they aren't dangerous.
Exactly. The fact that one of these systems spotted 3 IATLAs just underlines how sophisticated our eyes on the sky have become. They have wide fields of view, high sensitivity. They can pick up faint things moving fast against the background stars.
Okay.
So, yeah, while they're ready to warn us about impacts, they're also critical for finding any unusual stuff out there, including unexpected interstellar visitors like ATLAS. It means we're better equipped than ever to, greet these arrivals.
Whether they're threats or just amazing science opportunities.
Precisely. It's a great example of how investing in protecting the planet also gives us incredible insights into the wider universe.
Okay, so let's quickly recap our deep dive on 3ILS. We've talked about this truly massive interstellar object, potentially twice the size of Manhattan.
Which is just huge.
Right. And it's being watched super closely as it travels through our solar system, passing Mars and Jupiter. Its existence alone is sparking this intense debate among astronomers about its, quote, mysterious origins.
They're looking at everything, composition, path.
Yeah, and we now know it was spotted by our planetary defense systems, which highlights their double duty, protecting Earth and doing cutting-edge science. It's incredible, isn't it? Thinking that an object from another star system is actually here, visiting, giving us this, fleeting chance to study something that's traveled unimaginable distances.
Steering secrets from who knows where.
Exactly. From a completely different corner of the Milky Way. It really makes you appreciate just the vastness of it all, and that there are always new, mind-bending discoveries waiting, or in this case, just dropping by our cosmic doorstep.
And this raises an important question for you, the listener. What do these interstellar visitors like Oumuamua, like Borisov, now like 3I Atlas, what do they really tell us about all the hidden stuff traversing the galaxy?
Good question.
If we're seeing more of them now, does that mean they're actually more common than we used to think? Or is it just that our detection methods, our telescopes, are getting that much better?
Right. Which is it? Or maybe both.
Maybe both. And what could discovering objects like ATLS mean for, say, how planets form or get ejected elsewhere? Could there be totally different ways celestial bodies form across the galaxy?